In example 2, we're not given the bounds, so we have to find those. So in example 2, we're asked to find the area of the region bounded by y equals x squared and y equals 2x plus 3. So let's get a sketch of this just to have an idea of what we're working with. So let's graph y equals x squared. That's just our standard parabola. Of course, it goes through the origin, is symmetric about the origin. It's sort of a U-shaped curve. And then our y equals 2x plus 3, that's a line, right? It has a y-intercept of 3 and has a slope of 2x. So I'll just roughly get an idea of what it is doing. And then the area we're looking for is the area bounded by these curves. So it's going to go from here to here. And so we have to actually compute our bounds. So we need to know what is the x value here and what is the x value here. And in order to do that, we will need to find these intersection points. Okay, so what are the intersection points and how do we find them? So the easiest way to find these using algebra is to set these equations equal to each other. So if we assume the y values are equal, which they'd have to be in order for these two curves to intersect each other, then we can set x squared equal to 2x plus 3. So we're finding the bounds. And solve this equation, and these x values we get for this will be the bounds that we're going to use for our integration. Okay, so let's subtract 2x and subtract 3. So when we're solving quadratic equations, it's best to set them equal to 0 and either factor them or solve the quadratic equation or however you want to do it, complete the square. But this factors pretty nicely. Positive 1 and negative 3, multiply to give me negative 3 and add to give me negative 2. So I'll go x plus 1, x minus 3 equals 0. So that gives me two bounds. Negative 1 is the value that makes this 0, and positive 3 is the value that makes this 0. And so what do I know? I know that when I take this area that my bounds are going to be from negative 1 to 3. And then the only thing I need to put in now are what, we have to subtract the functions in the correct order. And so we're going to look here and see that the ceiling of this is played by 2x plus 3 and the floor is played by x squared. And so 2x plus 3 minus x squared is the integral we want to take. If you get these in the wrong order, it's no big deal. You'll just get a negative of the correct answer. So if you're getting a negative answer, it's probably because of that. Okay, so let's clean this up a bit. I'm going to write this as negative x squared up front and then plus 2x plus 3. All right, so take the integral. These are just polynomials, so not too bad. Okay, so now, so we just did the power rule a bunch of times, and now we're just going to plug our bounds in. So plugging 3 in, and then we'll plug negative 1 in. And so, 3 cubed is 27, then divided by 3 is 9, so I'm going to get negative 9 plus 9, 3 squared, then plus 9 again. Then over here, negative 1 cubed is still negative 1, so I'll get positive 1/3. Negative 1 squared is 1, and I get minus 3. Okay, so what are these? So this is just 9, right? Because I have a negative 9 plus 9, that cancels, and so I have 9. And then minus, this is negative 2 plus 1/3, and so this is the same as negative 6/3, that's positive, so this will be negative 5/3. And then, so what I'm doing is I'm adding 9 to 5/3. 9 is the same as 27/3, so if I add these two things, I get 32/3, which is the area between these two curves. And since we're not given bounds, we're computing these bounds, and we found that they were -1 and 3.